Let me quickly just share that link to the WhatsApp group again. So if you're not on the WhatsApp group yet and you want to join, please do. The link is now in the chat. If you can't access the link, please just send me a WhatsApp on 0837908387. I will post the recording and the presentation there. What I will do as well, if I see there's anybody new joining, I will post some of the previous sessions on there as well. Okay, if you can't access the WhatsApp, please just put your cell phone number in the chat. I'll then add you to the chat later on, or to a WhatsApp if you can't join. Okay. Okay, cool. So today's session, we're gonna focus on nonlinear functions. So we're gonna look at quadratic, cubic, exponential, log, and hyperbolic functions. If we look at what will most likely not be in your exam, it's the hyperbolic function, but they might ask some of those questions in the assignment, but they normally focus on the first four in your exam. Okay, so also what we're going to try to do, so please, when you get your final, or not final, just an indication of your exam dates, please start sending that through. I know it's still early, but we can plan extra sessions before you write exams as well. Okay, so quadratic, cubic, exponential, log, hyperbolic, that is the things that we're gonna look at this morning. So in there, we quickly look at what was in the learning objectives, but again, there's a few things that you will see that they can't really ask you in the exam. So they can't really ask you to plot any of the equations because it's multiple choice. You can't really see that. What they can do is to give you a plot of any of the functions and ask you which one is which. Okay, so that is one of the things that they can do. The other thing is that with those functions, they can ask you to work out, like we nearly did in chapter 2 or 3, I think, when it was linear equations and we looked at revenue, cost, and profit. So now we will do exactly the same, but we will look at it from a quadratic equation point of view. Then they can nearly ask you to manipulate a few of the equations. Again, not really. They're going to ask you to interpret because it's multiple choice. So what they can do is to give you a function and ask you to identify something in that. So it might be that they give you a quadratic function and they ask you to work out one of the turning points or something like that. So again, there's a few things that from a learning objectives point of view, they can't really ask. So it is more about if you can identify certain of the equations, which one is which, and then certain things within those equations. Okay, so are we going to tackle the rest of this morning? We're going to go through the theory, and then after the theory, we'll do some exercises as well that we can just see how some of the questions can pan out and what they can ask you. Okay, so the first thing that we're nearly gonna look at is a few different nonlinear functions. So we know the parabola, so that is nearly your x to the power of 2. So there's normally one turning point in it, and it can go up, it can go down, it can move around. So it does not always need to be in the origin. It can do that. It can do that. There's a few ways that it can look like, but we will look at how we get to that. I added this one, but you will probably not ever see this in. I just wanted to show you that you get weird graphs as well. So this was basically a function that only looks at anything that becomes a positive x. This is not something that you need to study or something or anything like that. It's not one of the cubic or square or any of those. I just wanted to show you something weird. And then we get the cubic function as well. This one is the purest form, where it is only x to the power of 3, and it goes through the origin. So there it has a turning point once and a turning point twice. So you can have in the same, you can have something that does something like that, which is also going to be a cubic. It will just have some more. Um, so that one will probably look something like, I don't know if it's going to be positive or negative, but it will look something like this. Okay, so instead of the pure cubic, you can get one that has different things because it has one turning point, two turning points. So that can also happen. So it does not need to be the purest form. So this is the pure form of x3, but you can have more variables. This is the purest form of x2, but again, you can have more variables that it looks something different. Let's go a bit into more detail. So on the quadratic function, you guys would see, and please, I will also, closer to the time, share with you some of the formulas so that you have that at hand. Normally, your exam is open book, that you can use resources. But I will also just give you, closer to the exam, a formula page that you guys can have at hand to work with. Okay, so the first thing that we need to look at is, for the quadratic, we first saw, now we had that perfect view. Okay, so in that perfect view, that was x to the power of 2. So it would have been going through that point for perfect view. Okay, so there was no x cutoffs there. It was basically everything going through the origin. When you add the bx plus c, suddenly you get a curve that is still a hyperbola, but now it goes through your x-axis. With that, they can now ask you to work out what those points are at this x-axis. So to work that out, we've got the formula of minus b plus minus b to the power of 2 minus 4ac over 2a. You don't need to know why it is like that. We can just use it. Okay, so this will give us the excess of those two cutoffs. When we get that x value, we will need to replace it back into this formula if we want to get, well, not really, because the y's are in any case going to be 0 at that point. So forget that thing that I wanted to mention. The y's is in any case going to be 0, so you don't need to work out the y. So you will work out the x, the y will be 0 at that point, and you will work out the x for the second one, and the y will be 0 because it is on the y equals 0 axis. It goes through that point. Okay, so, but that is to work out the two places where the x goes through, or the formula goes through the x. The other thing that you need to know, that point where it goes through the y-axis, that is equal to your c. Okay, so if you get that value of c as, say, in this instance, that was negative, so let's say it was minus 4, that cutoff of your y-axis is minus 4. Okay, so most of the time you will get a formula where you actually will know what the value of c is. Okay, they will most likely give you the formula where you know what c is so that you can just work out the x values. Then there's another important one that we need to know is this turning point. Okay, so this turning point, again, there's a formula for it. And let's take that h out. That h is just so that turning point is basically how you will work that out. The x value is minus b over 2a. So that again is a formula. You don't need to know how we got to it. You just use it. So when we need to get that turning point, the x will be worked out with a formula of minus b over 2a. And in this instance, if you need to get the value of y, you will need to put that x back into your original formula to get the value of y. We will go through an example later on where we will work this out. So I'm just giving you all the theory background that, again, if you write down a few formulas, but I will share with you, you have these things that you can work with. So on a quadratic function, the important thing is for you to be able to work out the x values, where the quadratic function will go through. And the other important thing is if there's a turning point that is not the same, you will need to be able to work out that turning point. That turning point you can work out with, again, the formula of x is equal to minus b over 2a. Okay, so that is when we look at at the quadratic functions. Then what you will get is that they give you, remember in study unit 2, we looked at revenue, we looked at cost, we said revenue minus cost is equal to your profit. So in this instance as well, we will get that we will sit with a revenue curve, a cost curve. We will need to work out profit, and then I can nearly ask you a few things around that profit. So here they could have now said at which X values there's no profit. So that you need to say this formula is equal to 0, and then we work out the X values. Okay, so that is how they might use your quadratic function to link it to revenue and cost and profits. It's not that you will now, again, they will need to give you revenue and cost information so that you can put it into a profit function. There's still things that they need to give you in a question that you know what to do. So they can't just something and say, work it out. They need to tell you, this is the revenue function, this is the cost function. You need to find out when there's no profit, how many product was produced. They can ask you to say, when you make a profit of 5,000, how many products did they need to make? So that is nearly things that they can bring in on the practical side, working from the quadratic function into something that you need to link back to a profit function. Okay, so they could have, and again, where they said you need to draw and those things that you really can't do, but they could have said, okay, let's plot it. So this would have been something negative, and then they could have asked you around what's the turning point, where you will again look at that formula of minus b over 2a to get a turning point. So wherever that turning point was, you will be able to use it in this function as well. So let's quickly look at what was the turning point. Only quickly doing the turning point. So that A, B, C. So if we needed to work out the turning point, the X would have been minus 260, because that is your B, over 2 minus 2. So 260 divided by 4 gives us 65. So our turning point there would have been where X was 65. Okay, so somewhere where X would have been 65. Okay, so that is how we will in practice nearly work it out. We could have then worked out what y is by putting back the 65 into that equation. So let's just do that so that we can just see what the y turning point would have been. So this is actually a nice example just to check. Okay, so 65 times 65, 4225 times minus 2, minus 8450. To 60 times 65. Okay, so I get that turning point was nearly at x65, and you guys can check later as well. Y is equal to 3450. Okay, so that is just quickly if I work it out, but it might be that somewhere I might have made a mistake, but that is nearly just a quick example of the things that they can ask you to work out. They could have asked you to then say, if there's no profit, what is that X values that you will go through? Okay, so that you need to then say, use this formula to work that out. So that could have been another thing from a practical point of view that they could have asked. Okay, so there's a few extra things that I also just want to show you guys. So when that a value, so that value, if that value is bigger than 0, our graph is pointing upwards. If that a value is smaller than 0, our graph will point downwards. So you can see here the -2, so I have drawn it downwards. What one of the students said, I think last year, also another way to look at it is, and we all love smileys. So when you're happy smiley, you're positive. If you're unhappy, you're negative, it goes down. So that is actually also a nice way to nearly look at it. If a is positive, it goes up. If a is negative, it goes down. So yeah, I thought that was actually quite a nice way of thinking it. We love emojis, so positive smiley goes up, negative smiley goes down. Then I've shown here for you guys nearly all of that things that we've now talked about in summary. So here's your two x-intercepts that we will work out with this formula. There's your y-intercept, that will be that c value. Here is your turning, or your turning point that we will work out with the two, where was it? The minus b over 2a. So this is nearly the whole spectrum of things that they can ask you if we look at the quadratic function. The other thing that they love to ask, and that's why I brought this in, because I've seen it last year that they talk about this, and I haven't picked it up in previous assignments or papers. So they sometimes talk about the discriminant, and that is the discriminant. So if you look at this original formula, this thing that is under the square root, that they talk as discriminant. So if that discriminant is bigger than 0, you will have a upwards trend with the two x points that you will have. When it is equal to 0, you will only have one intercept. Okay, that intercept can still be going up or down, it doesn't matter, but you will have one intercept. When that discriminant is negative, which means that you actually can't get something because we can't get the square root of a negative number. So that actually means that we don't have any x values. So then this would move up here, or if it's on the negative side, would have been here. So there's actually 0 intercepts. Because of a negative discriminant, you can't get a negative square root, so that automatically tells you that you can't have any x cutoff values. Okay, so this is just, I've seen it last year for the first time that they ask something around discriminant in your assignments. So I just thought let's just add it here if they ask something around discriminant this time again, but at least it is something that you've seen. It's not hidden on some page somewhere that one normally just flips over. Okay, then we've looked at it at the top one as well, but as your linear equations was, so if you had a supply and demand function, at that point we had break even. The same will, sorry, not demand, now I must, so when it is demand and supply, it is equilibrium. When it is total revenue equal to total cost, it is break even. So demand and supply at this point would be your market equilibrium. If it was total revenue and total cost, then we have break even. So very similar to what we had with linear equations. Is just remember what the difference is between break even and market equilibrium, because again, that might be something that comes up. So normally they love to ask one of those two for your linear equation, and then they love to ask it for the non-linear equation. So just be wary that you can get a non-linear equation where they want you to work out break even or market equilibrium. Okay, and also then remember, break even, total revenue equal to total cost. Market equilibrium is when the demand function is the same as the supply function. Okay, so you already can now see, again, when we talk demand, supply, market equilibrium, that you can see here we will start looking at producer surplus and consumer surplus, but that is in the next study unit, where we will look at the consumer surplus and supply surplus because of producer surplus, because of it nearly being some of the applications that we will look at. So Then, so that is all was quadratic. Then you get into cubic. So cubic functions, you can see this one is, as we had the previous way at the beginning of a session, this is the nice one. This is where you basically only have x to the power of 3. So it would have been only that. But here is one that there's one turning point there. There's a second turning point there. This is normally the ones that we will get, and you will see that it is a bit more complicated than the original of just x to the power of 3. Okay, so with this again, there's a y-intercept, so that plus 2 is nearly standard in all your formulas. That constant is your y-intercept. Okay, so when you see that constant, it is nearly standard that that will be your y-intercept. Then we will need to work out roots, and we will need to work out your maximum, minimum. In this instance, that would have been a minimum, that would have been a maximum. In this instance, there was not, it will both be 0 because it was at the same point. So we will be able to work out those points as well. Normally, when you get a function like this, what will happen is it will be more likely that you get so, or you can have it in that function as well, but that you will be able to start putting things together to get some factors. So nearly, oh, when did you do factorization and those kind of things? So that you will be able to identify factors that you will be able to use to get to those roots. We will use, and that I'll show again next week, we will use some differentiation to work out that maximum and minimum point. So we will use next week a lot also to see how certain of these things with differentiation we will be able to work out. So that again is something that is important that for you guys is the the application of some of these functions. We will use differentiation to get to some of the answers. The linear equation was easy. That's because there's no extra function, it's only a x. It was easy to look and solve the linear equation. The quadratic equation is also, in a sense, a bit easier because you do sit with a lot of formulas to assist you. But when we get to cubic, we first need to nearly get that 1x out, and then the rest of the formula then will be quadratic again. So then we can work with the rest to find out the rest of the information. So that is, but we'll get to that next week. Another one that we see they bring in also in your, specifically in your assignments, is exponential functions. I think what is important about the exponential function is you will see that it does not go past this x-axis where y is equal to 0. So everything is positive. So you will see that all your constants is positive. It might be a fraction, but it is positive. If it is negative, that will just be nearly that graphs are then all running like this, but again, it will not go across that x-axis where y is 0. So you won't get an exponential function that runs like that. Okay, you can't be, it is just not positive. Okay, so, or possible. So your exponential functions will always run nearly that it can't cross that x-axis where y is equal to 0. So that's nearly the big thing with exponential functions. It does not cross that line. So then, just to show you quickly the other one, where was the, okay, why did I not have in the log? Okay, so I must just, I thought I have the log function in. I will just check now in the next one. So I must bring in the log function for you guys as well. Again, log function is very similar to the exponential function, but with log function, it does not go past this y intercept again. But I will quickly just show you next week. I don't know why I haven't added the log function. I will just show you the log function as well. Oh, okay, so yeah, okay, this is the logistic growth function. So yeah, so I will bring in the log function. It's very similar to something like this nearly, where you can see it also doesn't go past, but I just want to make sure that we get the right one. They've talked in your study guide about unlimited, limited, and logistic growth functions. So these are nearly the three. To be honest, I haven't seen them talking about this in assignments or exams. The same with the nearly hyperbolic function. It's there, but it's very limited. So we will, towards the exam, go through examples of that it's also just covered. But to be honest, there hasn't been a lot of these two in any of your preps for assignments and exams. So just to show you the differences, so if it's unlimited, it's very similar to that exponential function. Again, it will not cross that axis. When it is limited, you will have, again, it will stop there, and then it will plateau out, very similar to this one nearly, where it can't go past a certain point. Okay, so that is nearly what you will also see. So the unlimited one, this one will just go up and up and up. The limited one, it will nearly, at some stage, it will be then basically between that and that barrier. The same nearly with your logistic growth one, but the logistic growth one, it will, the big difference between these two is that this one will be between 0 and whatever that point is. This one will go between that point, and then here it will go on. It will not do that to go to 0. There is also a limit. So it's 0, it's not its limit. It is maybe between 1 and 4. And then it's running nearly on that length all the way to that side, and on this side all the way it goes, so that it basically reach a point where it can't nearly grow anymore. So that is your logistic growth function. Okay, so the difference is basically the one can grow unlimited. This one is limited growth, and then this one is really, it is stuck between two lines. So to be honest, I haven't seen a lot of this in exams, but I will go through a few of previous exams and papers again just to see if we don't have at least an example of it, so that we do get you prepared if I throw it in. Okay, hyperbolic function is very similar nearly to this type of function. It looks a bit different because it takes a different shape, but it's also going between nearly two spaces. So because they give us that 7 in, and you will see the same here in that one is 3. So what happens is that this hyperbolic function will go all the way as close as possible to 7, and as close as possible it will go to 0. It can't be 0 because then that you can't divide by 0. So that is why it will never touch where x is 0, because you can't divide by 0. That is why it nearly goes infinity on this side. But because it divides by x, you can still divide it by minus x. So that's why it has basically the same type of graph on the negative side of x. So again, that will run as close as possible to 7, and that will run as close as possible to x equals 0. Again, it can't be 0 because you can't divide by 0, so that will just keep on going up, and this will keep on going along the line of 7. Okay, the reason why, again, it doesn't touch 7 is that you can't get as a 0. So just out of algebra, there's no ways we can get that first term to be 0. Okay, so that's why we will never touch that 0 point, because 7 point, because this will always be or just a bit bigger than 0. Let me rephrase. It will always be a bit bigger than 7. So it will always be a bit bigger than 7 or a bit smaller than 7, but again, never 7. So the same if we look at a point like this. So here we have, so it goes through that asymptote, but it is because that function looks a bit different. So if you look at this function, there's no problem in having x0 because you're not dividing by the x. Okay, so in this instance, no problem of having the x0. So you can have the x0 in that instance, but again, you will see that it runs, that it can't cross certain things. So there will still be a y and a x axis, even if it has moved a bit, but that will still be in place, that you can't move over it. Okay, so that is the interesting thing with hyperbolic, very similar to nearly this logistic growth in a sense that it will run between two barriers. So you will never be able to, in this instance, go past -1, and you will never ever be able to go past the 2 point. And then exactly the same on the other side, never past that 2 and never past this -1. So nearly with a hyperbolic function, you will always be nearly boxed in, if one can put it that way. Again, to be honest, haven't seen a lot of hyperbolic functions in assignments or in your exams. Doesn't need to say that it won't be there, but really haven't seen a lot of that being in any of your papers. So you guys can let me know if you've done assignments already for this and picked up any of these weird ones, nearly as I call it. If you needed to answer questions about that, you can just say in the chat. But it's normally the cube, the quadratic, the exponential, and sometimes the log that you will have. It's not a lot that you will see parabolic or the other one. Okay, so let's go into a few examples, I think. Okay, so let's look at the first example. Here they ask us that you need to work out the roots of the function. So the roots of a function is basically you need to work out those two x values. Where was it? Those two x-intercepts. Okay, so that is what we need to work out with the root of a function. Okay, so quickly think what you will do, what you will nearly look at to get that. Just jot it down. We will now go into much more detail to see what we will do to work it out. Again, I will share later with you some summary of all the formulas, that you nearly have a summary page with you, so that you don't nearly need to look at all these formulas and see which ones to use. Okay, so for this one, I'm quickly just drawing, not on scale or anything. That's positive, so it's a smiley that goes up. I need to basically get to That's the one root that I need to get to. That is the other root that I need to get to. Okay, so for that, I will use that formula that we've done here. So I would, where was it? And let me quickly write it down. The minus b plus minus b squared minus 4ac over 2a. Okay, so I will use that function. Some of your calculators might have it built into it. So just I think some of the sharp calculators might actually have it built into it, that EL1. For your assignments, what you guys are also actually allowed to do is you can actually, let's say you Google roots of variables. Sometimes there's online calculators that can do it for you as well. So to test. So I think there's sometimes nice calculators that you can use to just double check your answers. The root of function calculator. So you can basically, let me just, and I'll put the link in it. Let's just see if it now wants something. Okay, so you can see that you can build now in this very nice functions to work out your, so you can even go to a function that it's x to the power of 3 or something like that. Okay, so you can see something. Okay, I should have said x and all those. So but you can see, you can basically manipulate this and put things in. So please, if when you do the equations or do the sums, no problem for you to test it in a online calculator. Okay, my computer is so slow this morning. I hope I haven't lost you guys. Okay. Oh, struggling to get into the chat to put it, but I will put it into the chat as soon as I can. Can you guys still hear me? Just give me a thumbs up that I know you guys can hear me still. Oi.
Good morning, sir. I think we lost him. Yeah, but we could hear him earlier on.
I'm back. Can you guys hear me now?
Yes, sir.
Okay, awesome. Thank you. Okay, don't know what happened there. Maybe because I went onto that website. So there is the link to that algebra calculator as well for you guys to test some of your answers. Okay. Okay, let's continue. So let's look at this one where we need to work out the roots. So remember A, B, and C. So minus B, so we've got -1 plus minus B to a power of 2, so 1 to a power of 2 minus 4. What is A? A is 1. C is -6. And that we need to divide by 2A. So let me quickly. 1 to the power of 2 is 1. So -1 plus minus. That is 1. 4 times 1 times 6 is 24. Minus times a minus becomes a positive. Plus 1 divided by 2. So we've got, that is -1 minus 5 divided by 2. And we've got -1 plus 5 divided by 2. So -1 minus 6, or is -6 divided by 2 is -3. And on this side, -1 plus 5 is +4. So 4 divided by 2 is 2. So the root is -3 and 2. I just want to see what is, okay, so that would have been our answer of the -3 -2. Okay, so that is nearly how we were. Hello?
Would I be wrong if instead of using that quadratic formula, if I would just simplify it, open two brackets, put that 3 and 2, and then simplify from there?
You can do that as well. No
Okay.
problem. No problem at all. So you could have done that. So you could have done your basic algebra where you would have had those as the factors 3 and 2, because 3 times 2 will give you 6. So you can add exactly the same. Let's just quickly see. You would have had the 2 factors of x plus 3, x minus 2, because that would have been the same. So then you would have just said x plus 3 is equal to 0. X minus 2 is equal to 0. Then x is equal to -3. And x is equal to 2. Perfect. You could have done that as well.
Okay.
So that is what I would normally do, is I would normally go for that first to look if I can factorize it. That's normally what I would do as well. I would look at it to factorize it first, and if I can't factorize it, I will do the longer method of working it out. Question. I see there's a hand. Was it just to show that you couldn't hear me at this stage? Or did you want to ask a question?
Sorry, sir.
Do you want to ask something? No problem. Please.
Can
Yes.
you hear me?
Yes, I can.
Oh, okay. I thought the answer would be number 4, because on the equation,
Yeah.
our x there is positive. So I thought x will be +3 and -2.
Okay. So.
Not number 1.
Okay. So look at. So your factors
Mm.
of the positive and the negative.
Mm,
But then remember that is equal to 0.
yes.
So then you need to say x plus 3 is equal to 0. So then if we work it out, the x stays on the left-hand side, that 3 will go to that side, then it becomes negative. So that is why, so your next stage to actually working out the x values, that is when you see the positive x then becomes negative 3 and the negative 2 becomes positive 2.
Okay,
Okay,
thank you. Okay, thank you,
cool.
sir.
And I think that's great that you ask that, because what we a lot of the time do is that at this point we nearly say, okay, but the x is 3 and the x is minus 2. And the issue is that you get the answer set as well. So that for me is why, again, I told it to the DSC 1630 guys last night as well. A lot of the times in specifically DSC, so it doesn't matter if it's 1520 or 1630, they give you the option of the thing that you also think is right. Because, like you said, there's the free and that one we would never have gotten, that we never would have gotten. But they sneaky by putting in this one because it does reflect the factors that we had. And then you pick it because you forgot, I need to go one extra step. Okay, there's another hand, so please, your hand is raised, so please ask. I can't see the name, but I think your surname is Gafula. Please, you can please ask a question. Might be that we're struggling with connection as well. So at any time, please, you can ask a question. So if I'm going on, just stop me and say you have a question that you want to raise again. Okay. Okay, so what I've done for you guys as well is I have included the answers so that you can work through it. So, and here they've shown you and exactly what I've done, but then they've also shown you how you can do it with a factorization so that you can do both ways. Okay, no problem at all. Choose what's the easiest for you to do, and run with that, please. That is, again, in the exam, you timed, so you don't want to nearly spend too much time on things that you can, with the easy method, you can actually solve. Okay, so what am I now looking at? So, okay, sorry. Okay, so so here suddenly, and what we look at is nearly a combination of most likely what you will get next week. So I am going to add it into next week's session as well. So a demand function of a firm is equal to that, where P and Q represent for price and quantity. At what value of P is marginal revenue equal to 0? Okay, so sorry, this one should be next week's session. So gonna put it in next week's session. It's not gonna help us looking at that now without the background of next week. But nearly wanted to show you that you will get where that quadratic is combined with the marginal revenue and those kind of things, and then what we need to do. Okay, so here we're now looking again at a quadratic, where they say where X is the number of units produced, what is the value of a company's maximum profit? Okay, so this is a bit different. So at what point does the company make maximum profit or minimum profit? So let's quickly, so that is one smiley that goes down. So on this graph, at what point does the company make profit? Is it A, B, C, or D? Okay, at which point would you guys, and you can put it in the chat or just say, but at which point on this graph does the company make profit? Is it still okay, let me okay, so my screen is supposed to be on question 23 now, so cool. Okay, everybody says B. Okay, so at that point the company is making profit. Okay, so what is that point? What would be my X at that point? That would have been that turning point. So the minus B over 2A, so minus B, let's just get, and I'll always write that down for myself, but again, you guys can use, when I send it, that printed version, and you can have it in front of you. So minus B over 2 minus 1. Let's just see. Okay, so, and for 0.3, okay, so, okay, so that should have been looking a bit different. Let's just quickly do that. So the only difference now is going to be the turning point is on that side. Okay. At x equal to 3, that is the turning point. Now again with DSC, if you didn't read the question properly or correctly, you will see where x is, you get x, there's an option. Okay, but we want to work out the maximum profit, not the x. Okay, but that is why very careful when you work with DSC, because nearly as you go along that question and work out certain specifics of a question, they already start giving you those options. And very easily to make that mistake in the exam, you are under pressure, you look at it, you see, oh, free, I've got free, yes, click and go on. So just be very careful in the exam. They love to do this. So there is always like one or two of the options is options that is nearly as you get to the final answer. Okay, so just be very careful for that. Okay, so we now know x is free. So let's put in the value of x into the original formula, and let's see what we get. Okay, so 3 to the power of 2 is 9, multiplied by the negative, minus 9 plus 18 plus 7. I don't get that, or am I making a calculation error here? 18 plus 7 is 25, minus 9, 16. Okay, so I made it. And there is your option of 16. Okay, so careful for that. The other thing is careful for the 7, because that is where the Y cutoff was. So you can see that they put that into the answer set as well, just if you thought, okay, that might have been one of the points where you will make maximum profit. Okay. If the formula was, if that was positive and not negative, then it would have been the other way around. And then the wording should be, if it looks like that, the wording will be, where do you make minimum profit? Okay, so then that will be a minimum because you can't go lower than that. So then the wording will be, where will you make minimum profit? Okay, so maximum profit is at that turning point because you can't make anything bigger than that. So that is where you maximize your profit. Here is you can't go below that. So that is where you will minimize your profit. Okay, I also have put in the formula here for you. You will see when you do this, you can get that turning point with doing differentiation as well. So we will do that next week. So you could have gotten that minus b over 2a exactly the same by differentiating that. So that is why when we go to cubic, we use differentiation to get to the turning points. But that is, I want more time for differentiation. That one tackles that on its own. So next week we will look at differentiation. But you can basically, for getting to this point of 3, you could have used differentiation, or you could have used what we did, and get the turning point and work from there. Okay, so in here is just that you get used to differentiation as well. I want to see this last one. Yeah. So there is 2 questions that doesn't have answers that I got out of a previous exam paper. Okay, so you will see we've got 2 questions here that we're going to still look at. So roots of quadratic function are 2 and 3 minus 3. What are the coordinates of the turning point? Okay, so now this is a bit different. So now what we need to do is we're going to need to use factorization to get to our original formula. So if they tell us the roots are 2 and minus 3, and that is to the point made earlier, then our factors are opposite, minus 2 and plus 3. So if we worked out again what the roots are, it would have been x minus 2 is equal to 0. So x would be equal to 0. So you can nearly see when you get the roots, to put it back in to the factorization mode of the brackets, you will need to use the opposite sign in front of it. Okay, so now we've got the formula that we can work with. So now first, from this point, I don't know yet what my turning points will be. So I need to first work out actually what the equation will be. So it is x to the power of 2 minus 2x plus 3x minus 6. So yeah, probably very similar to that one, but let's quickly see. Plus x minus 6. Okay, so that is my formula that I need to work with. So now turning point, x is equal to minus b over 2a. So minus b 2a. So minus 0.5. Okay, so that is our one turning point. So I will look at x and say, okay, not that one. Might be. Not that one. Might be. And hopefully already in your assignments they have thrown out the none over above. At the stage they did take it out. At the stage they brought it back, but very seldom the none over above. Okay, so now we sit with 2 options. So we need to put this back into that original to see what the answer is. So minus 0.5 to the power of 2 plus 0. Or negative 0.5 minus 6. Okay, so that will be our final answer. So 0.5. So that will give us a positive, a plus 0.25. That will give us minus 6.5. So I'm sitting with a minus 6.25 as my other turning point. So there it is. So option 2 is the correct one. Okay, so you could have now seen a few different ways that they can ask it. So
Sorry, sir.
yes.
Can you please repeat the last step for me?
Okay, cool. So let's do this. Okay, so minus 0.5 to the power of 2 will give you positive 2.5. Then plus times a minus gives you a minus 0.5 minus the 6. So if you add all of that together, you get the minus 6.25. Okay, because it will 0.25 minus the 0.5 will give you minus 0.25 minus 6 will give you the minus 6.25. Okay, cool. So you could see that they can give you the roots. You will need to work out the turning point, or they give you the original. You need to work out the turning point. They could have given you the roots and just asked you actually to work out the formula. They don't need to go all the way to get to the turning point. So they just could have asked you which one of the following formulas is correct. Again, what they could have done, as in one of the others, they could have asked you what is the x point, and then they might give you 0.5 minus 0.5 minus 6.25 and 5.25. So again, they don't need to ask you the whole thing of this is the whole turning point. They could have just asked you even to work out the x value or the y value. But you can now see the differences in how they can ask the roots question, give you the roots, or ask you to work it out, ask you to nearly work out a function with it. The cubic function, the log functions, we will cover that in differentiation, because you can't nearly solve that on its own. You need to differentiate first the equation to make it in a simpler format for you to work with. So that's why we haven't really done any equations or examples now of cubic functions or anything like that, because to solve a cubic function, we will need to differentiate. And that we will do next week. So next week, we will only look at differentiation. Okay, so one last question. So this again is, I like this because in this one, you test a few things about the knowledge of a quadratic equation. Okay, so they've given you the 4, and let's see if I can just make this a bit bigger, that you can just at least see those equations. So I'm going to rewrite it in any case. So the first equation is y minus x squared minus 2 equal to 0. Okay, so they've put all of these equations into nearly a function that you're not used to. So they've done it first the y, then the x, and then the last one. Okay, so looking at it, it's nearly, okay, this is not what I'm used to. So let's rewrite all of them. Okay, so let's start with that one first. Okay, so you want to say y is equal to, because you want to actually see what is the equation. So that first one, I need to take the x to the power of 2 to your right-hand side, so then it becomes actually positive. And the minus 2 to the right-hand side, so it becomes positive. So that first equation is going up, and it goes through the point there of 2. So let's just look at there going up through the point of 2, going down point of 2, not going to be right, going down point of 2, not going to be right, up point of 2. Okay, so we're working at the moment. I've eliminated those two because of just one equation. Okay, so again, in your assignment or exam, don't answer all of them or rewrite all of them. Just start by the first one and see if you can eliminate a few of the options. Okay, so let's look at the second one. Y, take that over x to the power of 2. So we know this one is that ideal one. It sits here in the middle. So that is correct. See, on this one, it would have been correct. On this one, it would have been correct. And on this one. So still with that one, I still have two options. So remember, these two is out of play. Okay, so now I see one goes down, one goes up. In this one, 2 goes down. So let's look at the third one. So y is equal to x squared, because the minus x to the power of 2 goes to your right-hand side. It becomes positive x2, plus 3 goes to your right-hand side, comes minus 3. Okay, so it goes up, and then where it goes through is at 3. Sorry, minus 3. Goes up, minus 3, correct. Minus 3 goes down, incorrect. Okay, so we didn't need to go through all of them, but that is how we could have identified as one being the correct answer. Let's just finish the last one. So then we can just make sure. So y, positive x to the power of 2 goes to the right-hand side. It becomes negative. So it is the negative ideal, so it is the one that goes downwards, but it is at the origin. There you have it. There you have it. So option 1, all 4 of them ticks to it that it is correct. Okay, so that nearly is how I would also approach this. If it was me writing exam, I would have just started from the beginning and say, okay, let's rewrite it. Okay, I've rewritten it. Let's see. Okay, I could have eliminated 2. The second one, oh, okay, unfortunately, still both of them in play. The third one, right. I know it's only that one that is left. So that is nearly how I would look at it. They love to nearly write it in this format, so that you first need to make it into the standard format. And the reason why they do it is to see if you can transfer that negative correctly to the right hand side, because you guys would have now seen if you kept it as negative, there was an option for you. If you kept it negative, there was an option for you. So they love to do it because then they can test if you can move it from the left hand to the right hand side, remembering to change the sign in front of it. And unfortunately, it's nearly like some of those, if you've done it incorrectly, or if you've just read it now as, oh, John said, if it's a negative in front of the x square, it's the unhappy, and it's -2. So luckily there wasn't a -2 still here somewhere. But remember, we need to always put it in nearly this format to make it that we can, be x plus c, that we can use it. Okay. So that is it for today. We will look at this type, because you'll see this is definitely something that when we look at the formula, we will work with a quadratic, but we will need to differentiate it to get to your answer. So this we will cover in next week's assignment, that we first do differentiation first, all the types, and then we can go into some of the practical. Okay, let me just quickly again, before we say goodbye, I am going to stop the recording, but quickly, just if you